nothing may perhaps be the most uncontroversial subject material in the scientific world, mostly because it is not there. Scientists have a hard time arguing about its validity, because there is nothing to argue about. No one can possibly disagree whether it exists or not, because with a little thought it can easily be realized that it does not exist. Nothing bears the distinguish of being a scientific topic about something not being there, as opposed to studying the urinary tracts of mules which are not certainly there. The mathematics of nothing is really intriguing. Think about nothing in relation to the universe. How much nothing might you think the universe consists of? 70%? 9%? Wrong. Nothing makes up 99.9999999 of the universe. Every time there is something, there are billions of nothings to match it. On and on, forever. On the other hand, nothing, since it does not exist, can make up any part of the universe, because the universe is what exists. However, if the universe really is the universe, then it is all of existence. Sadly, it then leaves out nothing, since it does not exist. What is the difference between space and nothing? Space, those areas of what we call reality which are relatively empty of matter but can still be defined in both spatial and temporal terms. The translation is, we don't think there's much of anything there, but we're pretty sure we can define both where and when they are. Nothing, however, are those areas of reality which are empty of matter and cannot be defined in spatial and temporal terms. The translation is, we don't have a clue about where or when they are, and there probably isn't anything there. This one isn't quite as obvious, but cuts right to the heart of our thoughts about the origin and evolution of the universe. For an example, within the boundaries of the universe, there is both matter, stars, planets, gases, and so forth, and space, what is in between the matter. But what about beyond the boundaries of the universe? What's out there, and how do we describe its location and time? Since there are no reference points outside of what we know, location and time cannot be described. Indeed, we really shouldn't even ask the question where or when it is, because any possible answer would be meaningless. How about before the Big Bang? What time was it, and where did it happen? How do we define spatial and temporal reality prior to the origin of spatial and temporal reality? Since the astronomical powers that be assume that both space and time were created by the Big Bang event, neither could have existed before it happened. Therefore, since neither space nor time existed, there must have been no space or time. But who really cares? Since matter, as we understand it, requires space to exist within, there couldn't have been anything there anyway. I hope you learned something about nothing.